Hello, welcome everyone. Thank you for attending session 1A today on cross-disciplinary collaboration and partnerships at the 2025 RDAP Summit. This session is a Zoom webinar. Attendees are muted and cameras are all turned off. To ask a question, please use the Q&A feature that's at the bottom of the screen. This session will run from 1:15 to 2:15 Eastern Time and include 2 live presentations followed by 2 pre-recorded lightning talks with the last 15 minutes for an open Q&A. We will save all questions until the end of the session, but please feel free to submit your questions throughout as you listen to the presentations. When asking your question, please indicate the presenter you would like to direct your question to. And after the session, please feel free to continue the conversation and drop questions in the session chat on FeedLoop. Please remember that the Code of Conduct is in effect for the entire duration of this summit. The Research Data Access and Preservation Summit organizers are committed to providing an environment where all attendees can participate fully in the program and activities without fear of harassment or discriminatory behavior of any kind. There is a Code of Conduct helper available during this session. Lisa Chin is identified as a COC helper in both FeedLoop and here in Zoom, and you may direct messages to them if you need assistance. They can provide you with the Code of Conduct email address or the link to the incident report form if needed. To get us started today, I'm very excited to introduce Emmy Green, Amy Tsang, and Catherine Skinner from Invest in Open Infrastructure.
Thanks so much for having us. So I think Emmy's going to get our slides up. Thank you, Emmy. All right, so data sharing infrastructures are essential, we all know this, for the creation and sharing of knowledge. But they face all kinds of challenges. They've got declining revenues, limited operational funding at best, and tons of competition. And each of those things hinders collaboration as well. So in this talk, my colleague Emmy and I will share with you some insights on ecosystem level gaps that limit the investment and adoption of data sharing infrastructures. These all come from the work that we're doing at Invest in Open Infrastructure. We'll also share with you some models that we see for fostering shared efficiencies and community-driven practices that we think can strengthen the resilience of data sharing infrastructures and the ecosystem more broadly. We are, in terms of who we are, so again, I'm Catherine Skinner. I'm the Director of Programs at Invest in Open Infrastructure. Emmy will introduce herself as we get her into a speaking role in just a couple of minutes. What we're trying to do at Invest in Open is increase the investment in and adoption of open infrastructure. And we're doing that because we believe in furthering equitable access to and participation in research. We want to see open infrastructure become the default in both research and scholarship. But what do we mean by open infrastructure? So this is a common question. We get asked it all the time because of our name. There's even a whole series on this right now in Katina magazine, for those of you who are interested, that Lauren Collister is the editor for. She is one of our colleagues at Invest in Open as well. So research data access and preservation relies heavily on open infrastructure, and it's often grounded in both open values and open principles. What we mean when we say open infrastructure is kind of on this slide, though I will note that I love what Lauren Collister, who is a linguist, likes to say, which is don't define, describe, which is a much safer way to work with definitions. But open implies a willingness and readiness to be discovered, accessed, identified, integrated, reused. And then infrastructure, with that term, we're referring to the underlying systems, tools, instruments, protocols, platforms, but also the social networks that community relies on. Next slide. So what's limiting investment? So, if what IOI exists to do is to increase investment and adoption in order to establish open data sharing infrastructures as the default, what's standing in the way? So many barriers, y'all. And I know everybody on this call is familiar with many of those. They differ by stakeholder type, though. And the list that I have on this slide is by no means exhaustive. but it does give a smattering of some of the things that we think stop researchers, institutional adopters, and government and philanthropic funders as three big groups from engaging. The part that we want to focus on in this brief talk today is the part that 2025 is starting to reveal to be the most dangerous, which is the way that open data sharing infrastructure and open infrastructure more broadly is typically founded and funded today. So let's take a close look at how we found and fund our open infrastructures. Most of the open infrastructure elements that serve research data have sprung forth from an immediate need of some sort that is either captured or defined by a small group of researchers, often from academic institutions or labs, and often within a research proposal. And that proposal, I'll note, is almost always written in sunk cost time. So it's part of the researcher's job to bring in self-funding. They write as part of their job, hopefully. Now, librarians and, there are lots of us coming in from lots of different perspectives doing this. But let's say that proposal is presented now to either a government or a philanthropic funder, and the magic happens. It gets funded. Hooray! So from this start, the project's already in the red. It's already been subsidized by whoever paid the salaries of the authors. And then it typically goes further in the red from there. So the build begins and more magic happens. The project works. Like, let's say that this is fabulous. We got it. We are building infrastructure. But before you know it, the project funding's running out because it wasn't ever really enough to begin with. So the researchers persevere and they propose another project. Maybe they do this several times. They start with the typical trio of projects. We actually have a typical trio of projects. You get a planning project that maybe has a pilot piece, you have development, and then you have sustainability, which we all know doesn't actually fund sustainability. But maybe they're so prolific, these researchers of ours, that they even pull in multiple funders and they spread out multiple directions. No matter what that model is that they're using, they rarely make any profit. And here I mean profit with a little p, just money that you can actually invest back in the project that is in excess of what you've gained from usually the grants. So they build on grants, it's money in, money out, and they run on pennies and borrowed time. And eventually grant funding's not enough. And then they define services or membership models and they seek to diversify their revenue streams with those. But while they're doing that, they're still running on pennies at best. They don't ever ask for what they need. They ask for what they think they might be able to get. So they think about, okay, well, the threshold for a library tends to be 5,000 or less that you can ask in this year to get it without it having to go through a massive bureaucratic review. And so maybe they price their membership at $5,000, not because they've done the math to see how many $5,000 payments they need, but because it's the best they can do. The cycle just keeps getting more complicated. So what I want to nail down here before I hand off to Emmy is this is the typical trajectory of our successful open infrastructures. So with that, Emmy, I'll hand it to you.
So let's try to turn to some data to reinforce the claim that Catherine has just made, that open infrastructures, even the successful one in our research and scholarship ecosystem, are running on less money than they need and are being heavily subsidized by long-term funders and or host institutions. At Invest in Open Infrastructure, we've been investigating open infrastructure funding in close concert with more than 100 open infrastructures serving the research and scholarship ecosystem. Many of these, and I'll show some of the names that we're working with, are directly serving research data needs, whether they are standards, tools, services, or other types of open infrastructures. We've been working to understand their operations, including their fiscal models and their business environments. And almost all of them depend on, at least in part, soft funding sources, grant funding in particular. On the screen now, you can see two important research outputs. One of them on the left is InfraFinder, a live tool service or service by IOI that provides up-to-date verified information about open infrastructures in the research scholarship ecosystem. And you can visit that tool yourself in your own browser at infrafinder.investinopen.org. The second is our first State of Open Infrastructure report from May last year, which provided a snapshot in time regarding the trends in characteristics, funding, governance, adoption, and policy for open infrastructures. This is the list of the 57 infrastructures that were featured in our 2024 report. Again, in 2025, we're really looking to double that pool of infrastructures that we're working with. So what kind of funding are we talking about here in this funding data set? We're currently mainly looking at grant funding data. That includes direct mentions of open infrastructure names and the recipient, grant title, and abstract or description. And even with this narrow scope that we have set, the sums that are in our current data set are not trivial. So you can see in the top row there, the total amount of funding that we're investigating in this data set is 416 million US dollars. Grant funding that is there since 2000 for 57 open infrastructures. Now, if we look to this data set, one thing that immediately jumps to us is that open infrastructures are not receiving the funding that matches where they need the most. So on the right, you see the self-reported funding needs data from these 57 infrastructures. Operations and community are the biggest reported needs by a long shot, accounting for more than 78% of their overall needs, while most of the support that they're receiving is for R&D, for research and development, with 67% of the funding going in that direction. Based on our additional strategic support work that we've been doing with various open infrastructures, we also know that most grants do not provide operational funding to the open infrastructure. At best, they may provide this to its academic or nonprofit host institution, usually through some sort of indirect costs and overhead. And that really leaves us with a space where we have starving infrastructures that are just barely getting by.
Yeah, so I'll pick back up there and say that indirect cost and overhead, as most of us know, has made that barely getting by status palatable for a lot of the academic institutions that have hosted these infrastructures in the past. Those hosts can't afford to cover losses from these infrastructures without having that indirect cost and overhead. So not only is the soft funding providing the necessary funds for their new development for these infrastructures, it is often also subsidizing the operational costs, or it's allowing their host institution, especially if it's an academic institution, to do that subsidization through that overhead. Recent developments in the United States and also in other countries. I mean, Argentina and the Netherlands are two that we cite often, but France, I mean, this is not limited by any stretch to the United States. To cut critical funding and programs for research and education are posing a really significant risk of disrupting the global research ecosystem and access to it far beyond any one country's borders. And inherent in these cuts is a massive threat to the critical infrastructure that's necessary for sharing and accessing research at every level. So this is our tools, it's our training, it's our connectivity, it's also the availability of the actual research and data at large. So soft funding, we know, both government and philanthropic right now, is reducing or at least restricting for open science in these really interesting ways. It's also really compromising partnerships across different national borders, especially where the US is concerned. And through that soft funding decreasing or restricting, it's also decreasing and restricting for open infrastructure that supports scholarship. And when we look at the broader system implications of reductions to grants that are happening right now, funding to research institutions is, of course, also reducing starkly and quickly. I mean, Columbia is today's headline, or not today's headline, but has been the most recent headline. But every institution in the US is feeling it. Most institutions in the Netherlands are feeling it right now, too. There's no buffer, there's no escape route. And that means that another critical revenue stream is going to go quickly downhill for open infrastructures, probably July 1st of this year when academic calendars hit, which is service and membership fees. Next slide. If we wait to see how this all shakes out, we're going to lose much of what we've built. So we have made lots and lots of investments in open infrastructure. We have made sporadic, poor investments many times in open infrastructure, but it is what we have as our base right now. And our action or inaction is going to be a choice. So one of the things that we really want to see is for infrastructures that are in this boat to clearly and quickly articulate what their runway looks like and what a drop in grant funding and membership funding would do to their already thin margins. And then for you that are adopters, check in with your infrastructure providers right now, not with a glossy little, are you okay? But with an actual offer to help them articulate for their users and their members what they need and when. And then especially adopters in the US also need to think about how they can put anything and everything they haven't already tied down in this year's budgets towards those infrastructures who aren't necessarily asking for it right now. Think about them. Don't just think about your service contracts with vendors. Think about the open infrastructures too. And I'm going to hand back to Emmy.
As Catherine's saying, we are standing at a crossroad, and the challenges are significant. But I think we should try and not forget that with every crisis, it always carries with it a seed of opportunity. Whoops, sorry.
But I'll come back.
Actually,
do we want to just end there? I know we're at
yeah,
time.
sorry, Catherine, I'll let you wrap up.
So really, Emmy was going to do the softer, like, there are things that make this a really good opportunity moment, and they do. But then I'm coming in at the end to say, yeah, and it's an emergency, so let's all treat it that way. So, thank you so much for your attention. Look forward to questions.
Thank you, Catherine and Emmy. So next up, we'll hear from Erin Winter and Gabrielle Hayden from University of Oregon.
All right. Does Erin, do you have our slides?
Give me a second. Okay. And then, all right, is it working? Is it?
Yeah.
Okay, great. And let's see, is it scrolling properly? Let's see. Is it moving slides back and forth?
No.
Oh, give me a sec. Oh. Let's see.
I'd be happy to do it if you need me to, but.
Let's see, yeah, maybe could you share the slides?
Sure. All right. Is it sharing the right thing?
Let's see, yes, great.
Okay.
Welcome. In this talk on collaborative modalities for data services, we'd like to talk about our experience collaborating with external departments to build a high-performance computing workshop with a team of instructors from in and outside the library space. Collaborative instruction helped us reach students and faculties who would otherwise very rarely, if ever, used our services at the library, and we will continue to build these relationships through additional workshop sessions. So first, let's introduce ourselves. So I'm Erin. I'm a research data management librarian in UO's Data Services Department. So at Data Services, our offerings fall into two categories: one-on-one consultations and workshops. Because I have a background in software engineering, I specialize in workshops and provide consultations for topics like Python, Git, Bash, data management, and now entry-level high-performance computing skills.
Right, and hi, I'm Gabrielle Hayden. I have been working in the data services unit essentially since it was founded by Jonathan Kane, who's now at Columbia. We are right now 3 full-time employees. We're hoping to successfully hire a GIS librarian very soon. And in the 6 years that I have been here, I've really focused on building workshops. I had to laugh at the always be closing because I sometimes joke that when I was in the private sector, we had a sales team, and now I need to always be closing on convincing people to come to our free and openly available workshops. And I focus on those both because it's an efficient way to communicate with our patrons, but also because that then helps bring more students and faculty into the library and helps drive our consultations. And one of the important things that the workshops focus on is kind of basic data literacy and computational literacy needs. And one thing that has become very clear to me and to us over the 6 years that I've been working in data services is how the new computer interfaces obscure structures, basic structures of how computers work, like files and folder systems as a kind of model. And students don't know that that's what they need to understand. They have a real blind spot around that. So you can't just tell them, come and learn about this, because they don't think that they need to know about it. So you really need to hide that broccoli in the cookies. And we do that in a number of ways. And one really important one is through collaborations, including recently with Career Services, the business school, and as Erin is going to talk about here, Research Advanced Computing. So before we had hired Erin for a number of years, I'd been talking to Research Advanced Computing, which runs, or RACS, which runs our supercomputer, about how we should do more collaboration. But the RACS people, who are lovely and kind, are computer programmers and not focused on outreach, and didn't know even how to include us, and me not coming from a computer science background, didn't know how to make it so that I could use the supercomputer, let alone someone else, right? So when we were able to hire Erin with her background, I immediately worked on connecting her with those folks.
Yeah, so from the beginning, we knew that we'd need some kind of workshop solution with instructors coming from multiple departments, where the library would supply some components of the workshop because we already taught things like the command line, and then external departments, namely RACS, would provide instruction on the high-performance computing system. So when I came to UO, my prior experience with parallel computing was limited, but I had a lot of experience with command line programming, version control, and networked file systems. So I was confident that I could teach the beginner sessions, even if both the material and the advanced sessions was new to me. So I'd like to talk about the state of high-performance computing at UO. So UO's Talipus cluster is a supercomputer of 300 individual computers and growing, with research groups that rely on it to conduct computationally intensive research. So there is already a consumer base that is using Talipus to conduct research that they couldn't otherwise do. So Talipus is a Linux cluster that uses Slurm software to manage job scheduling, which makes it just like many other supercomputers at universities and research labs across the country. So there's nothing exceptional about Talipus's infrastructure. Instead, the challenges it presents to novice users are those faced by many interdisciplinary researchers who come to computational research from outside of a computer science background. So Talipus is managed by professional software engineers and architects who know a lot about computer science. The documentation assumes computer science domain knowledge, and graduate students being onboarded were given this documentation without really the acumen to read it or understand it. I once had a consultation with a student who opened the documentation given to them by a PI and said, "I don't know what language this is in." And so for them, just reading the documentation was not enough for them to use the cluster competently. But that's where the library comes in, because Bash is not a specialized skill. Parallel computing is, but Bash isn't. So the library already had the resources to meet entry-level command line instructions. The question was how to contextualize that command line exercise within a larger workshop series. So as Gabriel mentioned, we wanted to ground high-performance computing in the library because we had experience doing free and open workshops, and that we had practice instructing students who didn't have underlying computational fluency in computational methods, that we already conducted Python classes regularly for students who came in without a real understanding between like how their file system is structured and how their local machine is structured. So because we had that instruction experience and capacity already, we listed this workshop within our calendaring system, and we housed it within the library in the same room where we already conducted a lot of our workshops in Python, R, and version control. So high-performance computing, even at an entry level, is a complex topic. This was going to have to be a sequence rather than a one-shot. I worked closely with the support staff at RACS and stakeholders in neuroscience who knew campus research groups to design a curriculum that covered common problems for PIs like permissions, file transfers, and misconfigured Slurm jobs through coherent scaffolded activities. We also emphasized reproducibility and data management practices throughout, because as I'll get to in a later slide, this workshop was designed for a very specific audience. I joined the research computing staff in a conference room with a whiteboard. The first time I taught the workshop, I had a sense of where everything was going, but the lessons taught by the RACS instructors benefited me as well. By serving as the dedicated note taker, I learned more about UO's high-performance computing ecosystem, and I became more capable of answering questions about it because I got better at it as the workshop went. So, what was our resulting schedule? So we ended up with the following design, which I've tried to abstract it away because this is not really what this talk is about. So in this diagram, each block represents a 2-hour workshop session, and each color represents a week of instruction, so that you see that each week had a grouping of related topics. I've labeled each session with which organization provided instructors. As you can see, the library teaches first, lays down foundational skills that are applied in the remaining sessions, which assume that participants can interact with the cluster through the command line, because that is what the whole first week is about, is we spend 4 hours developing command line proficiency. Then our guest instructors take over the same library classroom to teach principles of job and research management, scheduling, and then in that third week, applications in popular languages like Python and R. And these applications were chosen by polling our participants and making sure like what languages they actually used. And Python and R come to the top of the list every time. If MATLAB had come to the top of the list, we might have done that. So this also meant that unlike our typical workshop offerings, we had to adjust our marketing strategy. Because in truth, the majority of people at the University of Oregon have no idea what Talipus is because it is not related to their work. Only a small set of research groups on campus are even eligible to use the high-performance computing cluster. So what we did is we restricted our enrollment to the 25 seats we had in our classroom because we wanted an in-person experience with a lot of assistance and room for questions. We collaborated with the project manager in the neuroscience department and identified faculty who had students in need of instruction. So neuroscience was a key starting department because computer science is not incorporated into the psych and neuroscience curriculum. And then these students in neuroscience became our first cohort. So how did it go? Actually, in short, our pilot session went really well. We brought new groups of graduate students into the library and got a lot of positive feedback in the process. But going forward, I had to make adjustments to our curriculum and then significant ones to our marketing strategy. I was able to use what I learned from RACS to adjust my own command line materials because now I knew where it was going. I started to understand the high performance computing portions as well. So first, we realized we couldn't make this a neuroscience only event, especially because we had stakeholders who were very interested who weren't in neuroscience at all. So with our second session, we still did that targeted list of PIs because we'd gotten such a phenomenal response rate. With only 5 PIs, we filled a room. But then we also marketed through a newsletter that goes out to the users of Talipus. So like if you use Talipus, you get an email from the weekly newsletter. And so we put a little like 100-word blurb about this. And then we again filled in a week in advance of the class. But as you will see in our next slide, we got a very different set of departments. So in the beginning, unsurprisingly, we really got psych and neuroscience departments only because we only advertised to psych and neuroscience. But then when we started advertising to users who were high performance, like anyone on this mailing list, we got a much broader range of departments, even departments like data science that I had believed were self-sufficient. What I realized is that all kinds of departments didn't have that foundation knowledge of high performance computing and best practices and how, and how it works. So that you'll also notice that in our first sign up, we had mostly graduate students with a handful of postdocs and faculty. And I added postdoc plus because I didn't have a postdoc checkbox. So in the second session we were able to distinguish between postdocs and faculty. And so you'll see we had a ton of PIs in the room who just wanted to sit for 12 hours to learn from us about best practices on Talibus. And we even let in a few undergrads because I learned that undergraduates intern in research labs too. So now we bring this back to libraries. So as we plan for a third workshop series after a successful first two, I feel confident that the library is a valuable collaborator in this endeavor. So if we try to advertise to the general public about topics like data management and data literacy, we genuinely don't get much interest. However, I find myself teaching exactly the data literacy skills that we don't advertise to workshop participants: where, why, and how to store and transfer files, the abstractions underpinning remote and local file systems, and I adjusted my pedagogy to reinforce those concepts through interactive lessons designed to orient participants in that complicated and heterogeneous structure of high-performance computing with different nodes for logging in and doing jobs. So what I would say is that most libraries might not have the resources to teach parallel computing algorithms. We don't have that either, but we do have the skills to teach foundational concepts that make researchers able to learn and even teach themselves more proficiently. I hope to leave all participants empowered to read and understand documentation and to troubleshoot and learn from the mistakes along the way, because I'm taking students from unable to schedule jobs to ones that schedule a job, get some output, and actually learn to debug it. So I'd like to thank all of our collaborators in the RACS and in the Lewis Center for Neuroimaging for guiding our work. And thank you very much. I apologize for the hiccup with the slides at the beginning.
Thank you, Erin and Gabriel. Our next talk will be a lightning talk from Alyssa Link-Silvone and Jen Ferguson from Northeastern University.
Hello, thank you for joining us for our lightning talk on investigating and addressing the needs of research support staff. My name is Alyssa Link-Silvone, and I am the head of our STEM unit at the Northeastern University Library. My co-investigator is Jen Ferguson, who is the head of Research Data Services at the library. For this project, we wanted to send a survey out to specifically research support staff members at our colleges for health sciences, engineering, and science. We aimed to target research support staff rather than research faculty or students who we heard from more frequently. About half the responses were from the College of Science, and the other half was split fairly evenly between the colleges of health science and engineering. With one of the first questions in our survey, we hoped to understand the types of work that our target audience was doing on a regular basis. Respondents' answers are listed in order of most to least mentioned. Somewhat unsurprisingly when considering this list, the top ways that respondents had interacted with the library in the last year were by reading or downloading journal articles, using tools to manage citations, and accessing literature databases. Given the type of work that folks were doing and how focused on electronic resources access our library is, we were pleasantly surprised to see that 36% of respondents had entered the library in the last year. Most commonly, folks entered the building to use library spaces, visit the ITS help desk, or join for a meeting or appointment. While the library doesn't often support what would be considered research productivity tools, we also see a significant amount of requests for them. We were curious to learn what tools are being used, especially knowing that researchers are potentially spending their own money or their lab's money on them. Of this list, some tools are provided by specific units on campus, but the only one the library offers support for as a whole are citation managers. We also asked about support expectations for these tools, should they ever be available, and about 75% of respondents expected either no or limited support. Respondents were asked to rank 9 potential services from what would be most to least helpful for their research. These are their top 3. Over 50% of respondents ranked statistics and ORCIDs in their top 3. Interestingly enough, every service idea had someone rank it in their top 3, and every single service idea had somebody rank it in their bottom 3. The bottom 2, which again had at least somebody rank them in their top choices, were web scraping or working with APIs, and authors' rights or understanding read and publish agreements. Based on this survey response, we did make some adjustments to our efforts to support this population. We have established a new research support staff newsletter sent 3 times per year, featuring an absolute max of 3 items per newsletter. We're adopting the less is more approach, even though we know we have a lot to share. We also had an immediate win in that one survey respondent requested that postdoc loan periods more closely match that of grad students rather than staff members. This was a more complicated request than we initially realized, but we were able to extend the loan period for postdocs. We also collaborated on a new Research Expo event that just happened in February 2025, bringing together service offerings from IT, the library, research administration, and more for a research audience. Thank you for joining us for this presentation. We welcome any questions you have. Please feel free to email us.
I'm Erin Foster, and along with my colleague Tobin Magley, we'd like to present this lightning talk on behalf of our team. This presentation was put together by a mix of data professionals from IT and libraries, or both, based on our experiences trying to have conversations across the compute and data silos. Even when everyone wants to work together, these conversations can be difficult for a variety of reasons. So how do we get started? I hope your conference bingo cards are ready. It wouldn't be an RDAP talk if we didn't mention the research data lifecycle. So in this vast oversimplification, data professionals and research computing staff occupy completely separate parts of the lifecycle often, so they have different perspectives and values. And if we start by acknowledging that, the respective expertise that each bring to the life cycle as well, how can we start to build partnerships and bridge the gaps between our work and our different areas of expertise? So many factors go into having a successful collaboration, and in this presentation, we want to highlight a couple of things that we found to be particularly important: having a common goal and speaking the same language. The first step is driving at a common goal. So we work separately a lot of the time, often in different parts of the data lifecycle, like we mentioned. So understanding the priorities and needs of your IT colleagues and framing what you want to do in terms of how it can help both sides is a great way to get started. But while you're talking, you also need to be aware that the words you use might not translate seamlessly into another discipline. So it's important to define the terms you're using in the context of your conversations and agree on a common vocabulary so you don't talk past each other. And I'll turn it over to Tobin to highlight some of the data management terms that show the different perspectives of research computing staff, data professionals, and researchers, and how these terms can be easily misunderstood.
So what are these different groups of people thinking when they say these terms? Let's start with metadata. Research computing staff is probably thinking about file system metadata. So when files were last created, who modified it, and things like that. Researchers are probably thinking about jamming a bunch of metadata in their file paths. And data professionals are likely thinking about formal metadata like READMEs, codebooks, and other machine-readable data standards. What about storage and backup? Research computing staff are probably thinking about scratch-based, so short-term storage on their cluster that people use their data on, and then once the analysis is over, they move it off. This is big on cost-capacity trade-offs, and they're likely not thinking about backup because it's there for such a short period of time. Researchers are thinking more medium term, and they're thinking about medium performance, so things that they can use on their computer to do analysis locally. Still has the cost-capacity trade-off. But data professionals are thinking more about preservation long term. So instead of a tent or a house, they want a fortress. They're thinking about data integrity, metadata so that can be used later, and having multiple independent copies to make sure that the data never gets lost. So what about sharing? Research computing professionals are probably thinking about Linux permissions. They're thinking about how to give access to the files researcher needs on their cluster. Researchers are probably thinking more about hitting the share button in a cloud storage system like Box or SharePoint or Google Drive. Whereas data professionals are thinking about providing public access to research data in a public repository with a persistent identifier. And what about archiving? Research computing staff are probably thinking about getting the data off the cluster once it's not being used anymore, packing it up in a zip file and sending it away. Researchers are probably not thinking about archiving, and data professionals are thinking about preserving things for reuse in the future, and possibly forever. So the take-home messages from this talk are mainly that we work in different parts of the same process, so we're going to have different focuses and values. So you can see research computing staff has more of a short-term goal when it comes to data, because the data is on the cluster for such a short period of time. Researchers are thinking more medium-term while the project is going on, whereas data professionals are thinking long-term about using data into the future. So we need to recognize where we are in the larger process to facilitate handoffs between teams. But in doing that, we need to define our terms so we make sure that we're talking about the same things, and use these shared terms when we talk to researchers so that the handoffs between our services become more seamless. The end.
Thank you to all our presenters. We're going to open up now for questions from the audience. As a reminder, please use the Q&A feature in Zoom at the bottom of the screen to submit your questions, and let us know if there's a particular presenter you'd like to address your question to. Thank you for that action prompt for all of us here today, Catherine. And now I think we've reached time at 1:15, and I want to thank all of our presenters in our audience for participating in this session, and we'll see you at the next session, which will start at 2:45 Eastern. In the meantime, please join us for a 30-minute break with our sponsors. You can find our sponsors in the exhibit hall piece from the conference page on FeedLoop. And please note that the next set of presentation sessions, section 2A and 2B, they're concurrent. So if you want to attend session 2A, I think if the organizer can confirm this, I think it's going to be here. But if you want to attend session 2B, which is on RDM and high performance computing centers, there's a new link. So go back to the FeedLoop sessions tab to find that. Thank you again to all of our presenters and attendees, and enjoy the rest of the conference.